Dear students, welcome back to this channel. Today's session is source follower and frequency response. In this session, we'll be discussing what is source follower. It is also called as common drain amplifier, or simply it is called source follower amplifier. And we'll study the effect of different capacitors like parasitic capacitors, as well as we'll study the frequency response. It is the last topic from unit number 1 of the subject electronic circuits. So first of all, this is the diagram for source follower amplifier. It is source follower amplifier circuit, which is also called common drain circuit. इससे पहले हम लोगों ने कॉमन सर्किट कॉमन सोर्स सर्किट डिस्कस किया है. दिस इज अनदर टाइप ऑफ एम्पलीफायर विच इज कॉमन ड्रेन एम्पलीफायर. सो हियर VI is the input voltage, RSI is the source resistance or resistance at input side. Then C1 and C2 are called coupling capacitor. मतलब इनपुट साइड कपल करने के लिए C1 यूज करते हैं, आउटपुट साइड जहां पे V0 लिखा है it is the output voltage. So to couple the output voltage and MOSFET, this is the symbol of MOSFET, capacitor C2 is used. This is gate terminal, source terminal and drain terminal of the MOSFET. We know the working of each and everything. Then RS is the source resistance. VDD is supply voltage connected at drain terminal and source is grounded. अब इसका AC equivalent circuit कैसे ड्रॉ करना है? What we have learned in earlier session, to draw AC equivalent circuit, wherever capacitor is there, make a short circuit. मतलब जहां पे कैपेसिटर है वहां पे शॉर्ट सर्किट करना है, मतलब एक सिंपल वायर कनेक्ट करना है, and make all the DC sources equal to 0 or connect all the DC sources to the ground. तो यहाँ पे this is VDD, that is DC source. It should be connected to the ground terminal. So this is VI, which is the AC source. So I am explaining AC equivalent circuit. So what we discussed, keep VI as it is, RSI will be as it is. अब देखो, this I need to connect it to the ground. So this VDD terminal, that means this will be grounded like this. So then drain terminal will be grounded because I am grounding this VDD. So I have drawn drain terminal over here. मतलब ये इंटरचेंज करके सिंबल ड्रॉ किया है. तो यहाँ पे drain terminal ड्रॉ किया है. ये this is the ground connection for the drain terminal. Look at the source terminal. It is grounded through RS. So this is the source terminal. ये source terminal है. It is grounded through RS and across source. I mean from the source terminal V0 is taken out. So same thing, from the source terminal V0 is taken out and from source to the ground RS is connected. About this part, look at this diagram. Here R1 is connected to VDD, but VDD is grounded. That means R1 must be connected to ground. तो ये भी terminal ground को connect होगा like this. But as I said, drain and source are interchanged just for the simplicity. तो यहाँ पे source lower side पे, यहाँ पे upper side पे draw किया. So the source and drain are interchanged. So R1, another terminal of R1 is connected to ground और ये C1 है, ये short circuit करना है. So RSI यहाँ पे एक डायरेक्ट वायर आएगा. सो RSI I have drawn only a single wire like this by eliminating C1. फिर R2 is already grounded, R1 will be also grounded. That means R1 and R2 will be in parallel. देखो ये ground connection है, यहाँ पे भी मैं ड्रॉ कर सकता हूँ. So I have drawn R1 parallel R2. This is the AC equivalent circuit for the source follower amplifier. The next part related to this is small signal equivalent circuit. एग्जाम पॉइंट ऑफ व्यू से क्वेश्चन आप ये एक्सपेक्ट कर सकते हो, ड्रॉ द स्मॉल सिग्नल इक्विवेलेंट सर्किट फॉर सोर्स फॉलोअर और कॉमन ड्रेन एम्पलीफायर एंड derive the expression of voltage gain. So this is the small signal equivalent circuit. We have already learned this in earlier videos, how to draw small signal equivalent model and so on. This is the diagram is same like the earlier cases, only few changes are there. यहाँ पे एक एक्स्ट्रा रेजिस्टेंस दिखा है मैंने, R1 पैरेलल R2. दिस रेजिस्टर इज कॉल्ड इनपुट रेजिस्टेंस डिनोटेड बाय RI. दिस इज द गेट टर्मिनल, दिस इज सोर्स टर्मिनल. The voltage between gate and source is VGS. This is a small signal model, so notations are small, V suffix small gs. This is current source whose value is gm vgs. It is same like the small signal model of common source amplifier, which we have studied in earlier video. R0 is output resistance. This is RS, source resistance, resistance connected to the source terminal and ground. So from this side, if you look at the diagram, then resistance will be RS and V0 is the output voltage. Now, how to derive the expression of voltage gain? Basically, voltage gain is denoted by AV, and it is the ratio of output voltage to the input voltage. So AV can be written as V0 upon Vi. At the input side we have voltage Vi, at the output side we have voltage V0. Look at the diagram. This voltage V0 is the voltage measured between this point as well as it is same as voltage between these points. So we can say like this, these two resistors, which is small r0 and rs, are parallel to each other. मतलब पहले क्या करना पड़ेगा, ये r0 और rs parallel combination लेना पड़ेगा. Then you will be getting one resistor after taking parallel combination, and the voltage drop across that resistor will be V0. So we can write the expression of V0 as, see, ये parallel लेंगे तो इसका वैल्यू आएगा R0 पैरेलल RS. ये सिंप्लीफाई करके कुछ एक आंसर आएगा, एंड वी विल बी हैविंग ओनली वन रेजिस्टेंस आफ्टर टेकिंग दिस इन पैरेलल. देन दिस करंट सोर्स, दिस इज अ करंट सोर्स, GM VGS is the value of this current source. This current source will flow through this resistance. मतलब जब ये हम लोग पैरेलल में ले लेंगे, एक रेजिस्टेंस आ जाएगा whose value will be R0 parallel RS, and this current will flow through this resistance. So the current into value of that resistance will be the voltage, because current into resistance is basically formula of voltage, and that voltage will be V0. So I can write equation of V0 as current, that is GM into VGS into parallel combination of R0 and RS. So this is the equation of, let us give some equation numbers. So this is equation number 2, which is the equation of output voltage. Now I can refer this diagram. यहाँ पे जो voltage है, I will make some, use some notation. Let us say this voltage is V in. ये सिर्फ voltage Vi है. This voltage is V in. So this is VGS, और यहाँ तक ये V0 है, मतलब these are same points. So at this, on every point voltage is V0. So this point's voltage is V0. So we can simply write the equation V in is equals to VGS plus V0. Very simple. This voltage is V in. This voltage drop is VGS plus this voltage V0 will be equal to the input voltage. So V in is VGS plus V0. Say equation number 3. Now put the value of V0, that is put equation 2 in equation 3. V0 के बदले में equation 2 यहाँ पे put करना है. So I will be getting new equation V in is equals to VGS. This VGS I am keeping it as it is. V0 के बदले में पूरा term put करना है. So plus GM VGS in the bracket R0 parallel RS. This is the value of voltage V in. Now let us take VGS common. ये जो VGS term है, it is common. So we can write the next expression as V in is equals to VGS in the bracket. देखो ये term common ले रहा हूँ मैं. So this term will become 1 plus GM, VGS common लिया है, in the bracket R0 parallel RS. Therefore VGS, what's my aim from this equation? I want to obtain equation of VGS. So ये पूरा term RHS में transfer करेंगे. VGS as it is रखेंगे, तो ये पूरा RHS में transfer करेंगे. So it becomes V in upon 1 plus GM in the bracket R0 parallel RS. देखो बहुत सिंपल है ये पहले यहाँ पे RHS में ये पूरा टर्म RHS में ट्रांसफर करेंगे, तो ये आएगा V in upon 1 plus GM R0 parallel RS. इक्वल्स टू VGS, तो मैंने साइड इंटरचेंज करके इक्वेशन लिखा है. सो दिस इज द इक्वेशन ऑफ VGS. Let us say this is equation number 4. In this equation we have V in. Look at the diagram. This is the voltage V in. So this is the voltage V in. We want to write equation of V in terms of VI. VI is the supply voltage. ये जो notation है RI, it is basically the notation for a parallel combination of R1 and R2. Recall the voltage division formula what we have learned in earlier videos. देखो RI मतलब combination of R1 parallel R2. So this is denoted by RI. V in is voltage drop. ये पूरा ground terminal है तो यहाँ पे ground है. V in will be voltage drop across this, means V in will be voltage drop across RI. Supply voltage is VI, so I can write equation as V in is equals to, what is the formula? Formula is this V in is across this resistor. तो जिस resistor के across calculate करना है वो resistor पहले लिखना है. मतलब I will write RI because this is R1 parallel R2 means RI into supply voltage. Supply voltage is VI divided by addition of resistance. Addition of resistance is basically RSI plus R1 parallel R2, but R1 parallel R2 is RI, so I will write it like this: RSI plus RI. This is the equation of V in. Now say this is equation number 5. Let us put equation of V in equation number 4. So I will get equation of VGS as it is RI into VI. Simplicity के लिए मैं ऐसे लिखता हूँ VI RI. Same thing, RI into VI is same as VI into RI. I'm putting value of V in, that is equation 5 in equation 4. So divided by RSI plus RI, whole thing divided by 1 plus GM R0 parallel RS. So this is the equation of VGS. For the simplicity, I will rewrite the equation. यहाँ पे लिखता हूँ मैं VGS is equals to same equation. I will write it like this: VI RI upon RSI plus RI in one bracket. This numerator term I have kept it in one bracket divided by 1 plus GM R0 parallel RS. Say equation number 6. Now we have got the equation of VGS in terms of VI. This is the value of VI. What is our AM? Basically we want to calculate AV. AV is V0 upon VI. So once when I got the equation in terms of V in, I have transferred it in terms of VI. Now put equation 6 in equation 2. So let us make this substitution. Put equation 6 in equation 2. इसका मतलब है VGS का ये जो value है, this value of VGS we need to put in equation 2, means in this place. So let us write the new equation. So V0 is equals to GM into this entire thing, VI RI upon RSI plus RI in one bracket divided by 1 plus GM R0 parallel RS. So I have put the value of VGS. This term R0 parallel RS will be as it is. So it is R0 parallel RS. Let us keep a square bracket. This term cannot be cancelled because this denominator contains 1 plus GM into this term, whereas this is a separate R0 parallel RS term only. Now last part, we want the equation of AV. AV is V0 upon VI. This is the V0 term. If we transfer only VI term at the RHS, then we will get AV, which is same as V0 upon VI. What I am doing, I am just transferring VI at the RHS. Remaining terms will be as it is: GM in the bracket RI upon RSI plus RI, bracket close, second bracket R0 parallel RS divided by 1 plus GM R0 parallel RS. So this is the final expression of voltage gain for source follower or common drain amplifier circuit. Next, parasitic capacitance. From the exam point of view, you may expect the question like this: draw high frequency model of MOSFET, rather N channel E MOSFET, and explain the parasitic capacitance or explain various capacitance. So this is the diagram which is called high frequency model. इसमें अलग अलग capacitance draw किए हैं. देखो, this is basically a P type substrate. Then two N plus regions are doped as we have discussed earlier. GM VGS dash is the current source. This is source terminal, gate terminal and drain terminal. Substrate or P type substrate is grounded. Now various capacitors and symbols are very simple to memorize. यहाँ पे मैंने summary लिख के दिया है. There are two regions of operation as far as this effect of capacitance is concerned. One is saturation region, another is non-saturation region. याद कैसे रखना है? In saturation region the current is constant, whereas in non-saturation region current is changing. So in case of non-saturation region, CGS is approximately equals to CGD. How to remember this? C means capacitor. Look at the diagram. I am talking about this capacitor CGS. As the name indicates, C is capacitance, G means gate terminal, S means source terminal. This is the gate terminal, this is the source terminal connected through RS over here. So CGS is capacitance between gate and source. Then CGD. CGD is this capacitance which is again connected from gate to the drain terminal. देखो यहाँ पे drain terminal एक resistance यूज किया RD in series with drain terminal, and this is the same point of drain terminal. So CGD is capacitance between gate and drain terminal. So in non-saturation region, CGS is approximately CGD, whose value is 1/2 WL. W is width, L is length, into COX. Value of COX is epsilon OX. Epsilon is permittivity, OX means oxide layer, and TOX is the thickness of oxide layer. Then in case of saturation region, CGD, this capacitance becomes 0, whereas CGS is 2/3 times. Same equation. यहाँ पे 1/2 है, this becomes 2/3 WLCOX. Now CGSP and CGDP. Look at this diagram. CGSP and CGDP. जहां पे भी P notation है, it is referred as parasitic capacitance. Look at the connection. This is the capacitance from gate terminal to the source terminal, while CGDP, ये value है CGDP. This is the capacitance connected between gate and drain terminal. So this is the CGDP, which is again parasitic capacitance. So these are called parasitic capacitance, and one more capacitance is shown in this diagram, that is CDS, that is the capacitance between drain and source terminal. So this is about the parasitic capacitance as well as all remaining capacitance. What is the use of this? I mean, what is the effect of capacitance as far as this MOSFET analysis is concerned? See, in major applications like in VLSI, very large scale integration technology, MOSFET is used as a switch. So the switching action must be instant. मतलब जब भी हम लोग MOSFET as a switch यूज कर रहे हैं तो ऑन और ऑफ एक्शन जो है स्विच का वो फास्ट होना चाहिए, बट ड्यू टू इफेक्ट ऑफ ऑल दिस कैपेसिटेंस the switching characteristics of MOSFET will be affected. Now the last important part, frequency response of MOSFET amplifier. You may expect the question like this: draw the frequency response and explain it for MOSFET amplifier. So this is the graph of frequency response. What's the definition? How this graph is plotted? It is graph of AV. AV means voltage gain, which is measured in dB, that is decibels. So it is the graph of voltage gain, which is AV measured in dB, versus frequency on x-axis. Usually this graph is plotted on the semi-log paper. Alright, so definition is a graph of voltage gain versus frequency in hertz is called frequency response. अब देखो इस रिस्पॉन्स में तीन अलग अलग रीजन्स दिखाया मैंने. देयर आर थ्री रीजन्स इन दिस रिस्पॉन्स. वन इज LF, that is lower frequency, second MF, that is mid frequency, and third is HF, that is high frequency. ये जो डॉटेड लाइन है, आई एम टॉकिंग अबाउट दिस डॉटेड लाइन, दिस इज द आइडियल ग्राफ. मीन्स आइडियली even if the frequency varies, the AV, value of AV, that is voltage gain, should not change, should remain constant. So this is the ideal graph. But in practical cases you are getting the graph like this. That means in LF, that is low frequency range, यहाँ तक है, you are getting the curve like this, which indicates that AV, that is voltage gain, decreases. ये downward arrow, ऐसा जो arrow मैंने draw किया है, it indicates that the value is decreasing. So in low frequency region, AV, that is voltage gain, decreases due to coupling and bypass capacitor, whereas in mid frequency, यहाँ पे ये mid frequency region है, AV remains constant. In high frequency region, AV again decreases due to the stray capacitance or internal capacitance. अब एक important term आप लोगों को आंसर में मेंशन करना पड़ेगा. I am talking about this point. This is the value, this is the value of AV max. At this point you are getting a maximum value. This is the value where you are getting 1 by root 2 times AV max. This is called half power point, or in another language I have marked two values, FL and FH. So lower frequency and higher frequency. These are the frequencies at which voltage gain reduces by 3 dB. So these are also called half power frequencies. So FL and FH are lower and higher half power frequencies at which the voltage gain is reduced by 3 dB compared to its maximum value. Now the bandwidth can be simply written as, remember this word, bandwidth is basically difference between frequency. So very simple, higher frequency minus lower frequency. So in this case bandwidth can be written as FH minus FL, that is higher frequency minus lower frequency. So dear students, that's it for this session and that's it for unit number 1. So thank you, thanks a lot for watching this video.